Hello. Uh, Good evening. No. Good morning. I didn't sleep well. So good morning, everyone. Today we're going to be talking about OpenSearch, Python, and Serverless. But before that, we're going to introduce ourselves. So my name is Laysa Uchoa. I'm here today with Julia Barabash. We are located in German, Munich, and we both work at a company called NordCloud. What NordCloud does is actually provide cloud solutions for our clients. So, let's start. Databases. So databases are used for store, manage, and retrieve data. This is clear, and I think, but what we have a lot of different databases. I looked once, and they say that they have more like 300 databases out there. So why do we have so many databases? The thing is, the way the data is, we need to think about ways of storing and retrieving. As we have different data types, or different ways of having data, we have a lot of databases. We have here key value databases, graphical databases, relational, non-relational, you name it. Every day, new company, new database. So let's go over a real scenario. We had this case that we had to choose one database initially when starting a project. And the database chosen was DynamoDB. Does anyone knows what's DynamoDB? Can you raise your hand? Okay, so a lot of people have experience with DynamoDB. As you know, DynamoDB is a key value database with support for JSON documents, but initially when you're using, it's fine. It works well. The thing is, we had it here the scenario that we are sending our data to DynamoDB by triggering a Lambda function, and we are also fetching the data from there. This is fine. The problem arises when you want to have a search, when you want that your users are able to search things. And DynamoDB is quite limited as a search engine. It's not really a search engine. So if you want to use DynamoDB for search, it could be quite complicated. So what would you do in this case? So what our experience in this case? This could make our clients very frustrated if they try to search with DynamoDB. But yeah, one thing you can do is actually, instead of just sending to DynamoDB and trying to work around DynamoDB issues with search, you can pick up another database. As I said, there are many databases out there. So one of the databases that you can use is OpenSearch. OpenSearch is an open source database. If you are familiar with Elasticsearch, OpenSearch is a fork of Elasticsearch from version 7.10. And with, as you know, Elasticsearch and as well OpenSearch, they are search engines. So they are perfect for search, if you want to implement search. So how would you do this in this scenario? Instead of when you are if you are triggering and send your data to DynamoDB, you would also have a Lambda that can send your data to OpenSearch. So you can either replicate from DynamoDB and fetch directly from OpenSearch. So this could work well, and this would also mean that you don't need to change a lot of things, because you would now still continuing a source of truth having the DynamoDB. This would make our clients happy, I hope. This was actually the first approach. Later on, instead of using Lambda functions here, we started using pipeline integrations. This way it could be like, we had some issues, right?
With pipeline integration, because with Lambda you need to maintain this Lambda. So we have like step functions for bulk, where you extract all data from DynamoDB to OpenSearch, and also we have like implementation on streams, where we react on delete, modify, and insert, and with pipelines
it works better. Yeah.
They did.
So this could be a first approach, but if you want to, you have a lot of scalability issues or something like this, maybe something like integration pipelines works better. So Why actually do we choose OpenSearch? I will tell you now why actually OpenSearch is a great thing for that. Because OpenSearch solves search problems. But what kind of search problems you find out there? One of them is that we live in a beautiful world where people speak different language. I myself am a polyglot, and I'm learning right now German. In German language, you have something called composed words. For example, a word that you need two words to it becomes one. For example, orange juice is not two different words. It will be just one word in German. If you think about this, if you are searching for juice, you would expect that orange juice will still appear, even if it's just a word. So you need that your database, your search engine, is able to crack this down and still find that word that in relevant topics. So it's just an example. Probably out there are more examples related to this. But it's cool that one thing is cool is that OpenSearch have supports for more than 30 languages. So it's quite a lot. And it normally, if you work in application, you should not just do it in English. You should consider your user, and it's nice to have this possibility. So OpenSearch is multilingual. What else is out there? I hope you can read this and you believe in yourself. But as you see, I'm not a native English speaker. So when I'm talking, I'm making mistakes. As well, if you are typing, you may make typos. You still would want that the user gets the relevant results. You don't want that just exactly the quote or just exactly something similar, right? You want to be flexible on that. And that's why OpenSearch use fuzz searching. So with fuzz searching, you can still find this, break this down and find, for example, if a typo happened or just a letter was inverted, it will try to find relevant results on your data. So this is a very powerful feature. Another thing that you may have noticed this when you are in search engines out there, which I would not name it, maybe Google, but you start to type something and the search engine kind of try to complete for you, based on maybe previous search, based on maybe relevance, or maybe, I don't know, someone pay for advertisement, this will show up. So this is something that OpenSearch also can help you. It is to have auto-completion. So kind of OpenSearch can read your mind, so to say, if you program correct. And you're very lucky today because Julia would tell you how you can do auto-completion, how you can implement auto-completion. And another thing, if you're coming from relational databases that have very strict schemas, and you need to be able to, if you want to change data, you have to change schema, and so on and so forth. This is very, very strict. This is something that OpenSearch can also deal with different, or at least give you an opportunity to do it differently. You have something called dynamic mapping, which means, for example, if you don't know your data beforehand, and you just want to send data, it's fine. You can send it, and OpenSearch will try to figure out which data types are related. And it works quite well. But of course, if you know your data well, it is better to be on the safe side and to have a mapping defined beforehand. This is quite nice, and these are just some of the features of OpenSearch. And today we're gonna dive in how you can actually do or understand and implement auto-completion with Julia.
Now we will talk about auto-completion and how to do auto-completion. And for this we will have small demos that will go back at the end of our talk. But right now we will focus on the logic, how we can implement this auto-completion. And for implementing auto-completion, there's right now four different strategies, but we just will focus on the three of them because they are very distinct. There are many different strategies. And the first one is the prefix matching. It's one of the easiest one, and also for this you don't need to do a lot of stuff because with this one you can reuse your current index, your current data that you have, and just on the top to build special query that you will query your data with, and it will act as auto-completion for your application. And for the implementation of this, we will use PyOpenSearch. It's a library. It's basically a wrapper around all API calls to your OpenSearch. And right now it has, for example, for managing indexes, for managing clusters, for managing your data documents, and a lot of other stuff that right now it's very hard to recall, but it's very powerful and just have a lot of wrappers around all methods that you need to interact with your OpenSearch. And right now we can see that on our screens that we have a client basically our connection with OpenSearch. And what we do search with it. We do a search request, and for this we just specify our index in case we will, in current demo, we will have index movie, but we have a lot of different movies, and we want to, for example, to watch something. And we watch something, we just remember one word, it's word Harry. And this word we will use it. But for using this word we need to use query. In case this, we pass the query, we pass the body, and after that we specify that the phrase should contain prefix Harry. In this case, the phrase, it will just search for the phrase with the beginning of the Harry, and we specify which kind of the field. We specify that it should be title, field, title, and prefix should be Harry. And after that, it will return all documents that have this prefix matched to us, and we can watch something. One of the advantages of this, you can also specify like fuzziness. Fuzziness is the value that you specify similarity between the queries that you have, values that you have in your field, and the person that the query, what's the value, because like in some cases it doesn't match one-to-one, people misspell it, and sometimes it's very hard to remember. That's why we have fuzziness where we can get still our value. Another way is a completion suggester. With completion suggester, it's more complicated one, because for this you need to define indexes. For you need to define your index, and when you define your index, you need to have to use special type completion, and when you use this type, cluster do pre-processing for you. It means that if the field have type completion, when you receive data inside your index, what OpenSearch does, it will store your data as a tree. It means that, for example, we have title Harry, and it means it's stored in the Harry and hello. And we can see that when we insert Harry and hello, what we will see is that root will be the first letter, after that it will be E or it will be A for Harry and or hello. After that, for the next, it also traverses the next letter as a leaf, insert like R. And once you query OpenSearch, it just do not like goes all data and match against, but it basically traverses the tree, so it will speed up your query processing and speed up your search. And for this, you need to specify also a special type of the query. For example, we will use suggest. It's a type of the queries that we need to use. After that, we need to specify suggest title, and additionally, you can have a few suggestions here, because suggest title is just custom name. You can have few parallel. For example, you can query another field or another field or another value. And after that, when you have your query, after this you return your data and you can show to user. The last one is search as your complete. Is also with this one you need to define your mapping for your index and also mapping for your field. Is the name of search as you type as well. It's a type of the field, and the idea of the field is split your string in words. It means when you receive your data, what it does, first of all, you specify n-grammas how you want to store. For example, you can specify a gramma 3, a gramma 4. In our case, we have a gramma 2. But we will go to this later. First of all, we focus on the title. When we receive our data, when we receive our string, we receive the string weather is great. What we do, we split this word and we'll keep this string as a string of arrays. So it will be index 1 weather, after that index 2 is, and after that index 3 great. After that, OpenSearch will build n-grammas. For example, weather is great. And during the search, also you can specify not only on the n-gramma on the words, but grammar on the letters. For example, GR or AT, so it will be a combination against letters as well. And when you do the query, what OpenSearch does, it will match against these n-grammas that also will speed up your searching, and you will get your request faster. And for this, you also need to specify your index, you need to specify body, but one of the interesting case, you can use one of the simple multi-match, and I like this because with multi-match you have a lot of powerful stuff, for example fuzziness, or you can use patterns and other stuff, and it's quite powerful, and basically you specify your query Harry, and after you specify the fields that you need to search, for example title and title with n-grammas. And it's what we need to do is basically to implement our auto-completion. But right now we will go to our demo, and here we have our demo. And one of the example, we have prefix magic, we specify Harry, and we can see that we are already typing something, and we have, for example, Harry and Bunny, Harry and Snowman, and so on. But for example, if I don't remember name Harry and I type like Harry, I have nothing because prefix match doesn't understand in this way fuzziness. But for example, if I use completion suggester and type Harry, it will still return something. It will also understand the Harry is for it. I will increase because maybe it's very hard to see. So you can see that Harry is misspelled, but now we get some result because it understands that Harry can be will be Harry or Henry or Herons and so on. In this case, your user will still get some results and he can select one of them. And it's everything for our demo. And if we do conclusion with OpenSearch, OpenSearch is quite powerful right now. On the reinvent, we have a new features that we also started to use, like pipeline integrations, where you can build easily integration between your database in OpenSearch, and it will help to import your data. And we're pretty fast. Also, there's a lot of optimization, a lot of monitoring stuff that you can also do, and you can optimize your cluster, and also you can use, for example, for powerful aggregation, analyze your data, or even track your logs with OpenSearch. And Laysa?
Thank you. That's it.
That's it?
Yeah.
So anyone, do you have any questions? Oh, okay. Let's start.
Okay. So why it does not use Algolia, for example? Because some already.
Algolia, why not?
Yeah.
Which one?
Algolia.
Algolia? I don't know.
It's the, I think, proprietary already built up search engine that already integrates the data.
I think it's because of the providers. I don't know, is it standalone or how is it, like AWS service or not?
Yeah, it can be deployed as standalone or both as a specific.
Yeah. What is the things that we didn't want to do because we don't want to support like standalone database, but usually we try to use like database as a service because in that case it takes overhead from operational overhead from us, and that's why we use like OpenSearch because like AWS proposed like this like as a service, and basically what you just need to define your
you need to define your cluster, and there's a lot like out-of-box like stuff. That's why we're using like OpenSearch.
Okay, thank you.
There was another question?
Yeah, so my question is, this was pretty similar, but I'm having an example of a different search engine. As you said, OpenSearch is a forked version of an Elasticsearch, yes? So why not using the Elasticsearch and using the OpenSearch? Because again, Elasticsearch can be deployed both on AWS, and if you go to elasticsearch.com, with a couple of clicks, you can deploy it out of the box, and it's already a database as a service for you. So all of the bells and whistles are there, so why OpenSearch and not an original Elasticsearch?
That's true. But in this version 7.10, Elasticsearch had a chain of license, and it was no longer open source in the full concept. You can still use it for logs, and if you don't sell it as a provider, you can still use it. But at this point, they changed the license, and it's not really open source in the full context. So you cannot use that and provide to others as service, for example. So that's mainly license-wise. But they were similar there. I believe now they are already walking different paths. So yeah, that's it.
I'm wondering about your interactions between frontend and your fast API. I saw fast API. What is it? It's a get each time.
I think we built something simple, but yeah, basically it's get every time. We just send request, and very simple.
Okay. Second question: isn't it a bit slow when you deploy it on the servers?
No, in our case it's no.
But of course, yeah. No, it's not slow in this demo, but it depends of the amount of data you have that it needs to look for. So it really depends. But you can always put more cluster or try ways of optimize.
Few more questions?
Yeah. So when you talk about search, do you mean query your database?
Yeah.
Yes.
Going for OpenSearch, I was thinking that with DynamoDB, there's an efficient way to really query DynamoDB table by using an index or the global secondary index, which is very fast. So why deciding to going for OpenSearch, which will cost more?
Not like it. DynamoDB is powerful in its own way. Yeah, if you define the index, yeah, it can be powerful, but you cannot. But there's again a limitation. I think you can define 20 global indexes and only 5 local indexes. Also, there should be like combination of fields. So if you want to search, for example, with OpenSearch, you can search across all data, all indexes on all fields. And it's like out-of-box functionality because it's basically one query. With DynamoDB, you need to build a lot upon it, and also you need to think properly about your indexes structure.
Okay, one more question from my side. So you said you initially started with DynamoDB, and then to augment it functionality-wise, you started with OpenSearch. So I'll challenge you. So why do you need then DynamoDB? Why can't you just go all in with OpenSearch?
Because we have event-driven architecture. It's that point, the idea that we have an event-driven architecture. It can be an transmission because it's all a big project. It has big functionality and imitates a lot of stuff. It's quite important project. But as I think it started like 4 years ago. And the idea is to have event-driven architecture when we react on the event, and that's why at that point we rely a lot of DynamoDB streams. That's why it's not very easy to go from DynamoDB. And it's not very easy to go from DynamoDB, and that's why we still have DynamoDB, but we also want to preserve and speed up our searching results and also give possibility user to search their data across different indexes. That's why we started to use OpenSearch. something?
One more question? No? There's gonna be a huge queue in the lunch area. So
I think it's already there.
yeah. So if that's it. Okay, no more questions. So thank you.